Hi everyone. This question wants us to take a look and just analyze this function and look at a couple of different ways of expressing it, okay, or visualizing it here. So g of x is equal to 1/3 x plus 1. So g, in this use of the function notation, stands for the rule 1/3 of the independent variable increased by 1. Now, this question gives us a domain to work on, -9, -6, -3, 0, 3, 6, 9. So in our table of values, we can write that down. So -9, -6, -3, 0, 3, 6, 9. So now I'm going to apply the rule. So 1/3 of the independent variable. So for this, this spot right here, 1/3 of the independent variable is going to be -3 plus 1 is -2. For the next one, 1/3 of the independent variable is going to be -2 plus 1 is -1. 1/3 of the independent variable in this case is going to be -1 plus 1 is 0. The next one's wonderful because if you throw a 0 in there, a third of 0 is 0 plus 1 is 1. A third of 3 is 1 plus 1 is 2. A third of 6 is 2 plus 1 is 3. And a third of 9 is 3 plus 1 is 4. So here are my points here. So on my graph here, I'm going to come over to -9, and I get -2. -6, -1, -3, 0, 0, 1, 3, 2, 6, 3, and then 9, 4. And there you go. Oops, sorry. Now I am quite tempted to want to connect these dots with a line, okay? Because when you're dealing with just the function here, if you ignore everything else and deal with just that line, well, that x could be any real number. I mean, I can multiply any number by 1/3 and add 1. But because the question says very specifically for the domain, I'm restricted to just those points. Okay? So it's interesting. Without this use of the word domain here, if this didn't exist, okay, then basically I'm left to my own devices to choose some values for my table of values. And this is only to kind of help me get a sense of the trend here. But then I would have connected the dots here. Okay, this could be representative of continuous data, but as soon as I give a domain that is just a discrete set of points, my graph becomes discrete.